One way to shorten the number of possible zeros you have to try using synthetic division is to use Descartes' rule of signs. Okay, we can figure out the possible number of positives and the possible number of negative roots. So here's how this little trick works. For the positive roots, you leave the equation just like it started. And what you're looking for is how many times did we change from positive to negative? We were positive, 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 positive. There were no sign changes in that. So that tells me that there are no possible positive roots. Okay, so that means if I've got plus or minus 2, plus or minus 3, plus or minus 4, I'm not going to try any of the positive, the 2, 3, or 4. I'm going to try the negatives. Now, here's how it works with the negative roots. What you want to do is you want to change that x to a negative x, like putting a negative 1 in there. So I'm going to have negative x cubed plus 2 times negative x squared plus 5 times negative x and then plus 4. Now let's see what we end up with. A negative x cubed is negative x cubed. Negative x squared turns positive, so that stays positive 2x squared. 5 times a negative x changes to a negative 5x, and then we have that positive 4 on the end. Now what we're looking for is how many times does it change signs. So I go from negative to positive here, that's 1. Positive to negative here, that's 2. Negative to positive there. So I have 3 times that it changes signs. Now these always come in pairs. So what I'm going to write over here is I could have 3 or 1 negative roots. Okay, and what that means is if I had 5, then it would be 5 or 3 or 1. You always go down by 2. Okay, so if I start out with 6, it would be 6 or 4 or 2 or none. Okay, you always go down by 2. So I'm either going to have 3 negative roots or I'm just going to have 1 negative roots. Now remember, we're determining real zeros. Okay, so there may be some imaginaries in there as well.